Hello and welcome to Eplan Spotlight. Today our topic is pre-planning. My name is Thomas Michels and I'm here with my dear colleague Sean Mulherin.
Hello Thomas, how are you?
Fine, thanks. Welcome to the studio.
It's always a pleasure to be here.
Cool. Pre-planning. A quite early phase in engineering, and maybe we have some different names for that. Pre-planning, basic engineering. So Sean, maybe it's good to have a first short introduction. So what is that topic, pre-planning? What is it about?
So pre-planning is part of the engineering process, and it's the idea to capture information early on in the engineering process and be able to leverage that data downstream in the other processes of the engineering. So when we work with Eplan Electric P8, we are already in the detail engineering phase. And the question I ask all of my customers is, where do you get the data to be able to start your detail engineering? And I get responses all across the board. Some use Excel, some use Visio, some use AutoCAD, some use a napkin, as a matter of fact. I've already seen napkins being used as a pre-planning tool to capture information early on, right? If you're in an airport, if you're in a train station and all you have is a piece of paper and a pen, well, just write up your ideas and put the system together on a napkin and give that to your engineers and tell them, now do your job.
Okay, let's call it the napkin strategy.
That's right, the napkin engineering, right?
Okay.
So
maybe let's have a look at the different ways to get that data. Yeah.
Absolutely. So instead of starting from scratch, what we're going to do is we're going to provide different ways to import information already inside of Eplan Preplanning. So we can import external drawings such as DWG, DXF files, or even images. And these can act as a layout already for the users to start identifying what type of control system they need for their machines. So you can already capture your motors, you can capture your sensors in that graphical environment with the imported images that you have. You can also take external lists, right? Like Excel. Excel is the tool of choice, or is a really fancy tool to capture information. So you have actuator lists, lists of motors, lists of sensors, and all of this information is already in an Excel file and it's already data. So why not use that data to already jumpstart your pre-planning? So take the information, you can import it inside of pre-planning and already have a jump start.
So this somehow picks up the topic that Excel is one of the most famous engineering tools globally, huh?
Absolutely. Funny
Okay.
to say, but yes, it is. A lot of engineers love Excel, that's for sure. And then you can also, in pre-planning, use a layout tool, such as instead of creating schematics or single lines, you can already in a layout lay out your system, and by placing that layout already capture all of your equipment, your actuators and your sensors for that entire control system that you need to design. Mm-hmm. And finally, you also can capture your I/O requirement, because if you have an actuator and you have a sensor, of course you'll need some I/Os to be able to control it and to start and stop them and get feedback from the machine.
Cool. I think quoting is also a topic that. Yeah?
Absolutely, because now if you do a layout of your system and you store information behind that system, then why not just report it and give me how long is it going to take to design it? How long is it going to take to program it? And how long is it going to take to build it and install it?
Okay.
So now you can also leverage the information in pre-planning to generate a quote.
Okay.
Right out of the system.
So then it's more that, let's maybe call it the technical focus in quoting, yeah? So to have these rough calculations and even to estimate how long it will take in engineering, yeah?
Absolutely. I mean, one of the goals is always to be able to create a plan and then have an idea of how much is it going to cost and is it feasible, or do I have to readjust and change the plan? You want to be able to do that early up front and not have it done at the end of the project.
What about an example?
Well, in an example here, we have, for example, as I mentioned, the napkin, right? The most famous engineering tool after Excel. Well, people capture information on a napkin. Instead of doing that on a napkin, why not do it in pre-planning directly, and that way leverage the actual graphical engine from pre-planning to start laying out a system. Here we've got a couple of conveyors, we've got some robots, and behind this is not just graphical data, it's also logical information that can be used in your detail engineering later on.
So I think it's maybe time to have a look at the system.
Before we jump into the system, let's take a look at the structure. Okay. Not only the graphical information is available, but at the same time, Eplan will create a very structured organization of your data so you can easily find it and easily navigate through the system to access that information quickly and easily.
Cool. So it's not only the graphical representation, there's real data behind.
Exactly.
And that, I think, is a typical topic we are talking today, digitalization. So it's not...
This is not analog, this is analog, right? So you don't, there's no data behind here. So you want to be able to use the data to be able to start your engineering.
So then let's have a look.
Let's take a look in the system and how that looks like in Eplan Preplanning. So I'm starting here with an empty page, and there I would like to start graphically capturing my requirements. So we need 2 conveyor belts, we need a turntable, we need 3 or 4 robots, and of course the power supply and the pneumatic system. So let's start with a conveyor layout. So here I take my graphical view of my conveyor system and I simply drop it in here. Now the beauty right away is you can see that I have in this graphics, I have a motor, I have 1 light barrier, and I've got another light barrier, and I've got a cylinder to actually close these clamps. Now what does this mean graphically? Or graphically you can see it, but what does this mean logically? Logically means that in my pre-planning navigator I can actually see now my conveyor 2. In there I can see my cylinders, I can see my light barriers, and I can see my motors. They're not just images, they're actually logical elements. And if I start looking a little deeper, you can see that I have my objects, but I also have the control system associated to these objects. Let's take a look at the motor. If I dive into this motor, now what you see is you see the name of the motor, the description of the motor, what it does, and you can also see some values associated to the planning time. How long is it going to take to program the software? How long is it going to take to install the system? How long is it going to take to plan it? And also you can put some cost estimates associated with it. Yeah. So that way at the end of the day, with a click of a button, pre-planning can generate a quote.
Okay. So maybe just one question. This is somehow scalable, right? So you can decide which depth of data you have here? Yeah?
Absolutely. You can add additional attributes if you want to capture more technical information, or if you want more commercial information, you can of course add additional fields. You can create your custom fields if you want to.
Perfect.
So now let's continue and let's add some additional systems. So here I'm going to take another conveyor, drop it in, and I'm going to take a turntable and drop that turntable in here. So now that I have, I'm just going to snap it onto the box, and there we go. So now I'm going to add a couple of robot systems, right? Robot is pretty much automation 101. So I'm just going to drop this robots, and again, using the functionality of the Eplan macros, I can use variations, and then I can also use value sets if I need to. So I got my two robots here for my conveyor system, and I'm going to add 2 additional robots here for my turntable. Now these are the field devices. Now of course I need some power, so I'm going to look for a power distribution panel. I'm just going to drop it in here, and because I've got a cylinder, which is a pneumatic cylinder, I need a pneumatic enclosure. So I'm just going to drop in a pneumatic enclosure. So my work so far is just placing some graphical entities that are putting my system together.
And you have, of course, the focus on function. So from the technical perspective, not really on dimension. Yeah. So that is functional view. Huh?
Exactly. Yeah. And the functional view, you put your pieces together to build the system you need. Yeah. And also, if you needed to add the technical function and you needed to size the various different entities, you could also do that right here and there if needed.
Yeah. Cool.
So now let's take a look at what we have. We've got our cylinder, we've got our conveyor belt 2, 3, we've got our turntable, and we got our 2 enclosures. So the huge benefit here is I can now leverage this information and start driving my reports or additional engineering steps if needed. So we talked about quoting. Now I'd like to do a quote. So all I'm going to do is I'm just going to go to my reports. I'm going to generate a report, and in here I've got a template for my quotes. So this is my planning object overview, and I'm just going to run it. And now you can see in the background, I've already got a report that was generated automatically. And this is my preliminary quoting. So this list gives me all of my actuators and my sensors. You can see my clamps, my light barriers, my conveyor motors, robot systems. And as you can see here as well, it also captures the I/O requirements for that particular system. It's telling you exactly how many digital inputs, how many digital outputs you need, and that way you can easily size the entire PLC system without even creating one single page of schematics. Isn't that cool?
Cool. What I learned is that often this is today somehow done by the most experienced engineer and has more to do with gut feeling than with data. Yeah? So they approximately know, yeah, mid-size of a plant, and then it's guessing. This looks much more data-driven.
Pre-planning also gives you the chance exactly to get rid of that gut feeling and to actually capture the gut feeling inside of your engineering environment. So all of these macros, these libraries that you create in pre-planning, they can now be used to actually capture your knowledge, your know-how, your engineering savoir-faire.
Okay. Cool.
So additionally to the I/O list, what you also have is you've got the planning times. And you can see here, you've got, for example, your planning, your construction, and your software programming times that are summarized here at the end. And if you want to, you can add your power consumption based on your motors, but you can also add the price. And here in this example, if I say my robot is $15,000, I've got $500 for sensors, $6,000 for a motor, I've got a total price of $84,000. But again,
a rough first estimation, huh? So that is experienced data. Huh? So
absolutely.
That, yeah.
And then also to know whether I'm in the ballpark. And then you just add another 10 or 15% profit margin, and then you can present the quote to your customers. So that was the first step, is the ability to, from a simple graphical layout, is to quickly and easily capture your control system and to leverage that information to generate a quote. But now I'd like to even go a step further. Why not take the information from pre-planning and then use it to drive your electrical engineering? So let's start with the pneumatic system. Here's my cylinders. I need a pneumatic air supply. So I'm simply going to go ahead and take this air supply and just drag it into my drawings. And look at that. Now I've got some pneumatic system drawings that have already been created, and I can see my air supply, my sensors, and also my valve manifold that was created based off of this pneumatic control cabinet. Now I need to place the cylinders, so I'm just going to simply find those cylinders in my tree. Here's one, and I've got another one on my conveyor belt number 2. So I'm going to select the cylinders, and just by selecting the cylinders, drag and drop, and now I'm creating all of my designs. Now that we have the pneumatic layouts, now I'm going to go for my electrical layout. Now let's design the power system. Power system, I'm going to take the electrical enclosures, drag that into my system, and now I created the power system. So here's my 400 volts coming in and distributing throughout the system. Now I can leverage the motors, for example, and I can drag the motor of my conveyor 2 into my page, and it's going to create the motor schematics. And if I'm going to go to the second page, now I'd like to drop in my light barriers. So I'm just going to take one light barrier, drop it in here, and then take the second light barrier and drop it in here. So you can work either with predetermined whole page macros, or you can also piece your system together as you go. So it's a very interactive approach to engineering, leveraging, of course, all of the information you created in the pre-planning page.
I think that gives you also somehow a freedom how to create finally the pages. It seems that they were generated completely, and now you just add some of the components where there is free space, so you can work in both modes, and it depends on what you like, so to say.
And pre-planning can keep track as well of what have you already placed in your detail engineering and what still needs to be added to the detail engineering aspect. So the same thing again for the other motors, very easily placeable, so I can just highlight those 2 additional motors and then just drag them back into my system. Actually, I got this one here and the one from the turntable. So highlight them and then just via drag and drop them into the system. And you can see the system is now building up the drawings. And of course, I got my 5 robots. So if I look at the four robots, I need to provide power to these. So I'm simply going to select my different robots, and just as well, same principle, just drag them in here. And now you can see I've got my power supply for each robot. So it's really the huge benefit in pre-planning is that now, instead of starting from Excel or a napkin, is now you start in pre-planning and you already capture all of your control system, and then you can leverage that to quickly and easily design your system in pre-planning.
And there is that data continuity, right? Because we are on that one system, so all the data that has been collected up front is then forwarded to the schematics. And is the data still connected somehow? Is it?
Absolutely.
Yeah?
If you look at this motor that I dropped in, I have a cross-reference. So I can simply click on the cross-reference and it navigates right to the overview. So the overview is now linked to the engineering design, and therefore, for example, in an instance of maintenance, in a maintenance system, you don't want to go from page to page in the schematics. You would like to be able to look at the overview, and in the overview say, this is motor that failed, where is it in my design? And you click on it and it takes you right there, and now you can troubleshoot the cable, the terminal, all the way back to the control panel for troubleshooting and maintenance.
Okay. And if you work like this, so you get this, let's call it for free, because there's no additional effort to create this this link. It's handled by the system, right?
That's the beauty of the Eplan platform. The Eplan platform has all of the solutions in one environment, and the data continuity is inside the platform. So whether you work in pre-planning, in P8, in Fluid, or in ProPanel, you're always working on the same set of data. And now finally, now that I've finished my controls design, what am I going to do? I'm just going to generate all of my reports. So now I can just say generate. I need a table of content, for example. So I'm going to go ahead and generate my table of content. I need, of course, a bill of materials, so a summarized parts list. I need maybe a list of device tags. So I'm going to select a list of device tags. I need a connection list, of course. And now you can just generate your reports, and now all of your information is available in the system. So here's my table of content with all of my pages. Here are my connection list with all of my wires. Here is my summarized parts list with all of my parts, and my entire engineering documentation is complete. So as you can see, in no time at all, I was able to put together a system that has about 20 pages, and just from one single page of pre-planning, making it really easy to lay out your systems graphically, and from there generate all of the documentation for detail engineering.
Okay. So now we started with that kind of, let's call it, functional plant overview here, or machine overview with the automation components. So is there also a different approach, because it directly comes up in my mind, maybe from process automation? We are thinking about P&ID drawings, where you see the process and you have the measuring points, the consumers, and all the sensors and all that stuff. So I think that works the same way, right?
Absolutely. And P&IDs are kind of the same thing as a pre-planning system, where you actually capture your process, and in that process you capture your control system as well up front. So it's nothing else than a machine layout just for process systems. And same principle, you design your P&ID, and once you've done that, then all of the data is then usable for your loop diagrams or other types of topics you need to do.
Okay.
And of course, don't forget Excel. So if we have Excel, then we can, of course, using pre-planning, we have an Excel import. And that Excel import is actually very powerful, because it allows you to take an Excel sheet, specify which columns in Excel are going to map to which information in Eplan, and therefore generate the data in the tree. So in this case, using Excel, you would have the tree, but no graphics. But at least you can leverage the data to start your detail engineering.
Great. And of course, you created some schematics just by dragging them in, and we saw these, let's call it, template drawings of schematics. Of course, this needs some preparation. Yeah, it's some kind of standard you use. Yeah.
And what I suggest is, if you already have a project in P8, then leverage those macros and then connect these macros to pre-planning objects. So then you build up a library, and all you have to do is link the pre-planning objects with the Eplan Electric P8 objects, and then after that, when you place one object, you automatically have the other one connected.
Okay.
So it's actually, the setting up is relatively quick. It's just understanding which information do you want from pre-planning to show up in your controls design world.
Okay. Maybe let's translate this Eplan wording macros. It's parts of schematics. Huh?
Yes,
yeah.
That's right. A macro is a part of that's right, a schematic template, so to speak.
Okay. And the more data that is in these templates, the better then is the possibility to do these reports, like really going down to connections, wires, and all that stuff. So it's really from A to Z, pre-planning or basic engineering, detail engineering, and then have a complete electrical or automation documentation, even including fluid.
Absolutely. So as you can see there, I did the fluid with the cylinders, right? So you have pre-planning giving you the overview, fluid designing all of the fluid power topics, Eplan Electric P8 doing all of the single line, multi-line designs, and then finally you can even pass it on to ProPanel to do your control cabinet layout if needed.
Okay. This sounds a little bit like a summary, Sean. Or is there more you want to tell us?
No, I kind of wrapped up the entire process, showcasing how you can capture data upfront using pre-planning and then leverage that data and feed it into the other systems like Eplan Fluid, Eplan Electric P8, and at the end, for your control cabinet, Eplan ProPanel. So leveraging the platform to capture all that data in one spot is the way you should do your engineering.
And that is really, I think, a good example for digitalization. So really have the data in a very early stage already digital available in the system, and then go from A to Z through that engineering.
Absolutely.
A keyword A to Z is, of course, that there is more to come. So maybe, Sean, you can tease a little bit the other spotlights that are in the queue.
Well, join me to the Eplan Electric P8 and Automation Spotlight, and as well, my favorite is the news of the platform version 2025.
And when we go really to that overall engineering and the all of engineering tasks, we also would have a look at the topic of standardization. We touched it in this session here, that it makes sense to prepare schematic templates and have snippets to reuse them. And then when we think, let's call it downstream in a complete idea, it is also to talk about service maintenance. So you can imagine the more information and that kind of documentation we saw in your presentation is forwarded to service maintenance. This is also big added value for the people that keep the plant running or the machine running.
That's right.
So then I say thank you very much, and thank you very much to you, Sean.
Thank you, Thomas, for moderating the session, and looking forward to seeing you in the other spotlights.
Okay, see you at Eplan Spotlight.
Bye-bye.